in our lesson 1.6, we're going to solve for a variable, but this time we're not going to get a number answer. Okay? All along, we've been solving for a variable. We've been trying to get x alone or a alone or whatever the variable is, and every time we've done it, we've gotten a value, like maybe 3 or -10 or 1/2, something, we've gotten an actual value. But when we are solving literal equations, like our learning goal says, I can solve literal equations for the indicated variable. Literal equations, as Jossie said, means an equation that has 2 or more variables in it. Well, if there's 2 or more variables, you're not going to be able to just solve and get a number. You're going to have one of the variables will be by itself, and everything else will be over on the other side. So solving for a variable actually means getting the variable alone. So let's fill that in. If they tell you to solve for an indicated variable, it just basically is telling you get the variable alone. So solving for a variable means getting the variable alone. No matter how ugly the other side looks, as long as we follow the process correctly, if that variable is alone, that equation is actually solved. Okay? So when there is more than one variable in an equation, it is often a formula for something. We worked with a formula in our exploration assignment that we did for today. What was that formula we worked with today? Anybody remember it? Abby? Yeah, length times width equals area. Little l times little w equals capital A, area. That's a formula. That's the area formula for a rectangle. So oftentimes our literal equations are going to be formulas that we should either recognize or at some point be able to recognize. And when we have it, we can rearrange it. Basically, that's what we're going to be doing. When we solve it for another variable, such as the area formula is already solved for a capital A. A is by itself. If they want us to solve it for L or for W, then we have to rearrange it. We have to get the L or W by itself. So here's a practice for us. Does anybody happen to know what formula this is? D equals RT, or little d equals little r times little t. Cody, what is that?
Diameter equals radius.
Little d often does stand for diameter. Little r does often stand for radius, but then what would t be? So does that look like a... Okay, and if we're talking about diameter and radius, then we're talking about what kind of a figure? A circle, aren't we? Are there any formulas that you know for circles that have d equals rt? I don't think there are any. Any of you drive a car? Or want to drive a car someday? Or a truck or whatever it is? Huh. And you guys should know what this is.
Oh. It's for when you fill up the gas, it gives you odd numbers.
Okay. Well, yeah, it gives you, when you fill up your vehicle with gas, you have to put so many gallons of gas in it because you can't go anywhere without it. But how do we know how fast we're going to go through that gas? How much time do you take driving your car? Miles per gallon. And how do you get better miles per gallon? Or how do you use more miles per gallon? By going further. You use more miles, you use more gas the further you go, right? How about the faster you go? Do you use more gas? Does it go faster the faster the speed you're driving? Typically that also affects it. Well, do you think now anybody, so I think T is going to be time, little r is going to be
range.
Not range, how fast you drive. Okay, let's just fill in the blanks here. This is the distance formula. And it's a very common formula. We got to learn it. D equals R times T is the distance formula. Little d stands for distance, how far. Little r stands for rate, how fast. And little t stands for time, or in other words, how long. All those play a factor. How far you have to drive, how fast you're going, will determine how long it will take you. How long you have and the speed you can drive determines how far you're going to be able to go. How far you have to go and how long you have to get there is going to determine how fast you want to drive. They all play a part with each other, okay? So when we solve the distance formula, right now, when it's D equals RT, what's it solve for right now?
Time.
No, this right here. What's it solve for right now? What's it solve for? In other words, which variable is alone? That's what solving means. Guess the variable alone. D is. So it's solved for D right now. It's solved for distance right now. So when they want us to solve it for T, what are they saying to us? It means get T alone. Get T by itself. Solve it for T. That's the indicated variable in this case. So we're going to write our formula down. D equals RT. I already have it there for us, and I've written off to the side. I want us to fill in the blank here. T is being what by R? Multiplied. I look at the side that T is on. It's right here. Right here. That's the one we want alone. T is being multiplied by R. Remember, to get a variable alone, you have to see what's happening to it. So what are we going to have to do? Divide both sides by that R. You undo multiplying with division. So here's what we're going to do. We're not going to show our division symbol right away. We're going to write that down again. D equals RT, and we'll show our dividing by R in this step. So our equation started, solve for D. We don't mess with it there. We write our equation down again, show our step of work of dividing by R. What's going to happen on the left side? Can you really divide D by R? And get like dr or something crazy like that? No. If we write it as dr, that means what?
D times R.
That means D times R. This is D divided by R, isn't it? So we're going to have to leave it like that. It's going to just stay D over R. You know how sometimes when we're solving for, and let's say we have this equation, 1 equals 3t. What would we do on both sides there to get t alone? Divide by 3. And these would cancel out. Can 1 be divided by 3 nicely? No. So in this case, we would leave it 1/3 equals t. Well, that's kind of what we're doing here. We're just leaving it. We're not messing. We can't really divide it, so we just leave it. These guys cancel out, and we end up with our t by itself. We have solved the equation for t. We're not going to get a number. We're not going to get a value. We're going to have an expression, an algebraic expression. Okay, one of the reasons that they want us to learn how to do that is, what if they give you a whole bunch of problems that they want you to do the same thing over and over and over again? They want you to find how long it took. They give you the distance, they give you the rate, and they say find the time. How long did it take? Well, it actually is going to be easier to use in this state, d over r equals t. So we're going to use our new named equation. It's still really the same formula, just rearranged. So we're going to use our rearranged equation, and we're going to, if the distance was 270 miles, what's that going to go in for? D. And the average rate was 60 miles per hour. What's that going in for? R. We'll be able to find how long it takes. So go ahead, you figure out how long is it gonna take to drive 270 miles at 60 miles an hour. Cody?
4.5 hours.
And so we would say, like Cody just said, you have to put the label on it. It's going to be 4.5 hours. How do we know it's hours? How do we know it's not days or minutes or, Cody, why is it hours?
Because when you're dividing 270 miles by 60 mph or miles per hour, you get 4.5 hours.
Yeah. So in other words, this H in here tells us it's measured in hours, doesn't it? Miles per hour. If it had been miles per minute, by the way, that'd be pretty fast, wouldn't it? 60 miles per minute. Okay, if it was miles per minute, then we'd have to say this is 4.5 what? Minutes, yeah. So we gotta know how do we decide what to give the label, okay? So you have two things that are gonna go on in some problems. They might want you first to rearrange the formula, get it solved for a different variable. Then when you do that, if they want you to find something, use your rearranged formula, substitute into it, and all you're going to have to do is a multiplication or a division problem or whatever it is, and you'll have your answer and you give it a label. Okay? So any questions about that? Anything along the way there confusing? Okay, let's go to the back side then. We'll do one more here. We have V equals LWH. Anybody know what that's the formula for? Julia? It could be a cylinder, possibly, but a cylinder actually has a little bit different formula. It's three-dimensional, I'll give you that. Cody.
Volume equals length times width times height.
Okay, so then it would, if it's a length times width times height, it has to be either a cube or some sort of rectangular prism. Okay, so more like, think of a box. So this room is a rectangular prism. It has a length, it has a width, and it has a height. It's three-dimensional. Length, width, height, 3 dimensions. Okay, a cylinder has circles at the top and bottom. So that one's formula is a little bit different. Okay, so we're going to put, this is volume, capital V, that's a capital V. If it doesn't look capital, make it look like it is. And these are small letters. Volume equals length times width times height. That's what's really going on here. So we're supposed to take that volume formula and we're supposed to solve it for H. What's it solve for right now? V. It's solve for volume right now, isn't it? Solve for V. They want us to get it solved for H, or in other words, they want us to get H alone. They want it to be solved for height instead. They want it to be so if we're going to use it to find a bunch of heights of different prisms, you could use it very easily. So let's take a look at it. V equals LWH. H is being, but look on that side where H is. This is what we want to get alone. And maybe this is what you're going to need to do sometimes. It's just box that up and say, you know what, that's got to be by itself. What's happening on that side with it? So H is being multiplied by what? Both L and W. It's got two things it's being multiplied by. It's being multiplied by L and it's being multiplied by W. So we can kind of make this into a one-step thing here, okay? So what do we do to undo multiplying? Divide. So we're going to divide by, and we're instead of saying we're going to divide by L and W, we're going to divide by the two of them together right away, LW. So it's already written here. We're not going to mess with it there. We're going to write it again. And we're going to divide both sides by LW. So we're solving an equation. That's what we're doing right now. We're just solving for a different variable is all. How do you feel about LW going into V? Probably not gonna be, can we do that, do you think? No, so what we're gonna do is we're gonna write it, leave it as that. We're gonna say V over LW. Just like when we get a fraction, we just leave it as a fraction. Equals, well, these L's cancel, these W's cancel, and we have H by itself. Here's our equation, the volume formula for a rectangular prism solved for H instead of V. Not going to get a value, but we have to rearrange it properly. So any questions? Now, you have to hear me on this. Please do. I mean, really listen, because you're going to be tempted to just be canceling away like what we're doing here. Anytime you darn please. You're going to be like, oh, we need to just, there's one upstairs and one downstairs, I can just cancel those out. We can only do that when it's straight multiplication like it was. We had straight multiplication up here. We had straight multiplication down here. That's the only time we can cancel like that. Let me give you an example of a time you cannot. If this had been L plus W upstairs and W downstairs, I could not do that because there's an addition sign here. I could not do this and say this is L. Can't do that. So we can only do it, so this is a big no, don't do that. We can only do it because we had multiplication up and multiplication down. We can get away with canceling like that. Okay? Okay, now let's take our formula. V equals, or V over LW equals H. Use our formula, our rearranged one. Don't use the old one. This is going to be a lot easier. Use our new named volume formula. It's in terms of H instead of V. Volume of a rectangular prism is 180 cubic inches. Where's that going to go? In for V, yeah, it's going to go in the top. It's going to go in for V. We don't need to put the cubic inches, by the way. We can leave the label out of our work here. The base has a length of 5 inches. Where's that going? For L. Times the width. Do they give us that? Sure do. Width of 4 inches. So we're going to put that. 5. So we have 5 times 4 down there. What is the height? That's the one we're looking for. We're looking for H. Okay. So what's the first thing we're going to do before we even put our fingers to our calculator? What's the first thing we're going to do before we put our fingers to the calculator here? Abby? Yeah, 5 times 4. What is 5 times 4, class? 20. You guys don't even need your calculators. We can do this. When you have a 0 up and down, we can cancel those. 18 divided by 2 is? 9. Or in other words, 20 goes into 180 9 times. Okay, and those are 9 what?
Inches.
Cubic inches.
Okay, let's have a vote. Are those 9 inches? Nobody's voting for inches. Or are those 9 cubic inches? Oh, that's the popular one. Well, Cody, you didn't vote for either. Do you have a different choice? We were voting for inches or cubic inches for our label. Okay, this is a what? This is a height. We just found this height is 9 something, and we're trying to decide if it's inches or cubic inches. Okay, I want you to think about that. What was the length measured in? Inches. What was the width measured in? Inches. What do you think the height should be measured in?
Inches.
Inches. Yeah, it's inches. These are inches, not cubic inches. Where do the cubic inches come from? What's measured in cubic inches? Cody?
I don't know where you get cubic inches.
but Lajasi, what's measured in cubic inches? Not area, just volume, is, because what happens, what do we do, Cody, to get that?
You're multiplying, because cube means 3, so you're multiplying 3 by 5 inches, 4 inches, and 9 inches, meaning
So
the
now,
value would be cubic inches.
yeah, so we now know that the length is 5, and those are inches. We know the width is 4, and those are inches. We know the height is 9, and those are inches. We're taking inches times inches times inches. Inches times inches times inches is inches cubed. And 5 times 4 is 20, and 20 times 9 is 180. I'm feeling pretty good about that because that's what they said the volume was, didn't they? Okay. We have to know how to label these properly. You know, when you can multiply with numbers all you want, if you don't really understand what that number should be labeled or what it represents, then we're not to where we need to be. Okay? So, anybody have questions about this last problem before we call it amen? Okay.